You can be a highly capable engineer and still make poor technical decisions. The problem isn't intelligence, it is judgment. Most engineers are trained to optimize for correctness, speed, and delivery. The feature works. The tests pass. The deployment succeeds. The dashboard is green. And yet, a month later, usage is flat. Incidents are increasing. Small changes trigger unexpected failures. The system feels harder to work with, not easier. Nothing is technically broken, and yet the decision was poor. Because technical decisions don't always fail at the code level, they fail at the system level. This video is part of the Engineering Judgement framework, a structured progression from disciplined execution to engineering authority. Today we are exploring why smart engineers make decisions that create long-term problems even when their code is correct and their metrics look healthy. The first reason is local optimization. Engineers naturally optimize what they can see. Latency of a service, performance of a query, deployment frequency, story completion. These are visible, measurable, and hence rewarded. But software systems don't reward local optimization. They reward alignment. Imagine a team redesigns a search engine. The architecture is cleaner, the code is efficient, the rollout is smooth. Response time improves significantly. Technically, the release is a success. But user adoption barely moves because the relevance of the search results was never validated. User behavior did not change. Business impact remained flat. The decision was technically strong but practically weak. Optimizing a component is not the same as improving a system. The second reason is the metric illusion. Metrics are necessary, but metrics are not judgment. Dashboards typically show uptime, latency, throughput, error rates. What they rarely show is user experience. They don't show hesitation. They don't show confusion. They don't show friction in the workflows. They don't show the workarounds users invent. They don't show when a user gives up and never comes back. They don't show whether the system actually solved the problem it was built to solve. You can be fully data-driven and still be directionally wrong. When we measure what our code does instead of what the system achieves, we confuse activity with impact. Green dashboards can coexist with a failing system. The third reason is short-term incentives. Delivery cycles reward speed. Performance reviews reward visible output. And once a software ships, we call it a win. Very few environments explicitly reward slowing down to examine trade-offs, naming the risks out loud, or thinking through what this decision will cost a year from now. Hence, engineers optimize for what is rewarded. They make releases quickly. They simplify locally. They defer structural concerns. Not because they lack the ability, but because the system around them reinforces that behavior. Over time, these small optimizations compound, and what looked efficient in isolation turns into systemic friction. So what does good technical judgment require? First is seeing beyond the component. Strong engineers don't just ask, does this function work? They ask, what does this change in the system? What new dependencies are we introducing? What assumptions are we hard-coding into the future? What becomes harder 6 months from now? Second is thinking in consequences. Every technical decision introduces maintenance cost, operational risk, scaling constraints, organizational dependency. Good judgment means evaluating those dimensions deliberately. Today's convenience often becomes tomorrow's constraint. Third, measuring impact, not output. Output is shipping a feature. Impact is changing user behavior. Output is reducing latency. Impact is increasing reliability under stress. Output is merging pull requests quickly. Impact is making the system easier to evolve. The difference is subtle, but over time it separates execution from authority. That is why engineering growth cannot be accidental. You don't develop judgment by writing more code alone. You develop it by strengthening how you evaluate systems, trade-offs, and consequences. The engineering judgment framework breaks this progression into levels: execution, ownership, system thinking, judgment, and finally authority. The goal is not simply to write better code. It is to make better decisions over time. Decisions that remain sound as systems scale, teams grow, and pressure increases. If you have ever looked at a system and thought, everything works, so why are we struggling? That's the gap between execution and authority. In the next episodes, we will examine the patterns that help close that gap. And if you would like to see the full progression, you can find the complete engineering judgment framework at paragchitnis.com.